Section 5.2 or 5.4, we're doing example 3, indirect measurement application. We're definitely doing the mid-segment theorem and applying it here. Here's our situation. Anna wants to find the distance across the base of Capulin volcano, an extinct volcano in New Mexico. She measures a triangle at one side of the volcano as shown in the diagram. And so what they're asking us to find is, well, what is AE? What is this particular thing right here? I might need to change to white so it shows up a little bit. So what is AE? That's what they're asking us to find. And if we know a little bit about the mid-segment theorem, this should be a no-brainer for us. If we understand the relationship between a mid-segment and the side that it's parallel to, okay? First of all, you have to ascertain that it actually is a mid-segment. How do you know it's a mid-segment? Well, first of all, when you look at your triangle, you see that this side right here is 700, this side is 700. So that means point B is a midpoint, okay? And then this side right here is 920, as is from C to D, that's also 920. So this is a midpoint. And thus, the line that connects those two midpoints together has to be a mid-segment by definition. Okay, so hopefully that makes sense to you. You do need to establish that first. Make sure that you are seeing the correct relationship, that BD is actually at one of the three mid-segments in that triangle, and it is. Now, what we're going to know is that because of this knowledge, BD is going to be exactly 1/2 the length of AE. And that's what we're trying to find is AE. We were given BD. BD is 775. So 1/2 of what is 775? So just move your 1/2 over. We'll multiply each side by the reciprocal. So you're going to double 775. And you're going to get 1550 is the length. It's going to be 1550 meters is the length of AE. Okay? So that's just a little bit of an application, but you do have to recognize from the figure that it's, first of all, you're dealing with a mid-segment to begin with, or else you're going to be very confused. Check it out as yours. I'm going to give you a +1 on that one. Suppose Anna's result in example 3 is correct, that AE actually is 1550. To check it, she measures a second triangle. How many meters will she measure between H and F? So that, you know, if her AE is correct at 1550, then what should HF equal? That's what they're asking you there. Okay, so check that, try that, and write your answer down, and we'll check it in class tomorrow. Thanks for listening.